All right, class, so this is the objective 4.4, applications of linear systems. We've been talking about linear equations and solving linear systems. Now here's some real-world problems that we can use linear systems and solve for certain things. So it's all about word problems here. So here are some examples. We talked about two kind of process of to solve a linear system. We talked about substitution and elimination. At this point, I'm going to let you choose whatever method you like to work with and you become good at it, okay? But here are the steps to solving word problems, okay? Linear system, applications of linear system. You always need to define your variables. You have to pick two variables, x and y, a and b, whatever variable you want. Make sure that these variables make sense, all right? So you don't get confused. Don't just stick to x and y every single time unless you actually label define your variables right from the beginning. But sometimes it's easier if I'm talking about hamburgers and soda, I'm talking about children and adults, if I'm talking about whatever I'm talking about, I try to label according to what I'm trying to solve for so I remember, okay? So use x and y or a's and b's or whatever variable makes sense for that case, all right? The next thing is you always writing two equations. Is always two equations. For this unit, for this purpose, we're always writing two equations. I always like to ask myself, is one equation about cost? The other equation is about how many, okay? How many? I like to ask myself these questions so I know what I'm dealing with. There's always two equations, and it's very, very important for you to keep track of your equations, the information in each equation, so you don't confuse yourself. Okay, one equation usually is for quantities. How many tickets am I selling? How many students are in the class? How many of something? The other equation sometimes, it has to do with cost. How much am I paying for tickets? How much am I paying for this hamburger and soda? So there's always two equations. Label that so you keep an understanding of what each equation is representing. Sometimes it means something else. Sometimes there's two equations about cost. So it's good to label your equations, okay? Sometimes you're dealing with two equations that has to do with cost. Each equation must have same units, all right? If I'm talking about how many people are in the classroom, boys and girls, I wouldn't put that it equals $20.50. That doesn't make any sense at all. So make sure that the units are the same. If I'm talking about people, then it equals a total of people. If I'm talking about how much I spent on something, then that equals a dollar amount. So make sure that the units make sense. If you're setting up equations, just throwing numbers together, you're not going to get the problem done correctly. Solve using any method. At this point, guys, I'm not going to make you use a specific method, okay? In mathematics, you be good at something and you try to be good at something else later and you keep on improving each time, okay? But it is good to be good at both methods, substitution and elimination, all right? Pick one that you're really good at it and work with. And then state your solution in a sentence if you need to, okay? Or an order pair, or a x, y type of order pair. Now, x, y is more if we're dealing with just an equation, a linear system that we have no clue what it's about. But if I'm talking about a word problem, an application, I want to say a sentence. I want to say how many we have, how many students are in the class, or how much I spent on something. So I would like a sentence form for the word problems here. And then check your solution. Does it make sense what you found? Negative amount of dollars doesn't make sense. Negative amount of people doesn't make sense. Sometimes you have positive numbers, but it doesn't add up to the total number that was given in the beginning. So check your solutions. Just do a quick little check in your calculator or mental math, or just a little work on the side, okay? So let's put all this here into one word problem here. I'm going to keep this notes by my side because I'm going to refer to it all the time. Here we go. The sum of two numbers is 70, and their difference is 24. Find those two numbers. Okay, I have no clue what these two numbers are. Absolutely no clue. So the first thing I'm going to do is I'm going to say let x be one number. Okay, one number. Let me just put the number sign. Let x be one number, and then let y be another. The other number. Okay, let y be the other. So I'm dealing with two variables. Have no clue what they are. But I know that maybe the x can be the smaller number, and y can be the larger number. I really don't know. We'll find out when we start solving. This kind of word problems is much easier. Students love this kind of word problems because it says the sum of the two numbers is 70. There's my equation number 1. I'm going to set up my first equation. If I add x and y together, x plus y, the word is always has to be the equal sign, okay, in this case. So x plus y equals 70. Now the next sentence is what we're going to write our second equation. And now here's the next sentence. Their difference is 24. So I'm going to write a sentence about the difference of these two exact same numbers. If I add them, adds to 70. But if I subtract them, it equals 24. Okay? So there we go. You have your system. You successfully wrote two equations for these two sentences. We're trying to find out what are these two numbers. Okay? So let's go ahead and solve it. I have x plus y equals 70 and x minus y equals 24. Here's my little system. Okay? I am going to use the process of elimination because it's pretty much given to us already a variable that is opposite of each other. When a y here and a y here are completely opposite of each other, they add up to 0. A positive y with a negative y adds up to 0. But then I have one x plus another x. Remember, I'm adding these two equations. So 1x plus 1x equals 2x. Okay, so I took care of the left side of my equal. Okay, if I cover here, my left side is completely done. The y's add up to 0. I don't need to write plus 0. Now let's take care of the other side. 70 plus 24. I am adding this, so it equals 70, 80, 94. Okay, so we're adding. We're not subtracting. We're adding these two equations together. Now, if you divide by 2 on both sides, divide by 2. I'm going to get x by itself, and that's 45, 46, 47, right? That's 47. Okay, so there we go, 47. X is 47. I know that x is 47. Now let's go back to the beginning and solve for y. You need to go back. Pick any of the equations. It really doesn't matter which equation you pick. Okay? So I'm going to pick x minus y equals 24 or plus y. It really doesn't matter. Plus y equals 70. I already know that x is 47. So 47 for my x plus the y equals 70. If I subtract 47 from both sides, we get that y equals, let me see, is that 23? Yep, that's 23. Okay? So y is 23. Let me check to see if I did my calculations correctly. Sometimes we do it too fast. Even me as a math teacher, sometimes I do my numbers too fast and I forget to check my solution. So let's check. Does 23 plus 47 equals 70? Let's see. Well, that's 23 plus 47. 3 plus 7 is 10. That's 40, 50, 60, 70. That works. Check in your calculator. I'm just checking with my own mental math here. Okay. When I subtract them, do I get 24? Let me see. 47 minus 23. Do I get 24? I sure do get 24. Check with your calculator. It works. So I know that these are the answers. I can give an answer as an order pair, or I can just say x equals 47, y equals 23. And that is our answer. Okay? So I'm checking here. This was just a check. I used mental math, but you can use calculator. You are going to be allowed to use calculator on the test. Okay? So remember, we're always writing two equations. In this case, the x was not the smaller number. The x was actually the larger number, and the y was the smaller number. We didn't know about anything about this x and y. That's why it was hard to decide which one they were. Okay? All right, let's go to another question. Let's do another problem. So you are selling tickets for a high school basketball game. Student ticket, so the student tickets cost $3 and general admission tickets cost $5. You sell 350 tickets total. So this is a very important information here, 350 total. And you collect 1,450. That's the how much, okay? How many of each tickets did you sell? So we're interested in find out how many. All right, so let's define our variables, okay? Variables. What variables we're gonna use? All right, so I'm selling student tickets. I'm gonna student tickets. I'm gonna let that be my S. And the general tickets, I'm gonna let that be my G. So it pretty much helps me. S is for student, G is for general. So when I'm solving, I'll know what I'm dealing with. Now let's write two equations. So that was my first step. My second step is, let me write two equations. One is gonna be for how many. And the numbers I used here are gonna be used, I can't use it again. So how many? I have no clue how many I sold, but if I add them up, the students' tickets plus whatever how many I sold of the general tickets, I know I sold a total of, you sell 350 tickets total, so 350 tickets. That's how many I sold. Now let's talk about a second equation. How much? How much did I make? That's a good question, huh? How much? There's a question mark right here. How much? Well, how much does the student tickets cost? The student tickets cost $3. So 3 times S plus, how much did I charge for the general? I charge $5. So 5 times the general admission equals, how much did I make? $1,450. 1,450. All right? So that's what I sold total, how much? So there it is, my equation 1 and equation 2. Let's rewrite it nicely over here. S plus G equals 350, and 3S plus 5G equals 1,450. I know I'm not showing label signs here, the dollar sign, but I know that's what I'm dealing with. This is my how much, I know that. Okay, so let's add these two equations together. Now, some students prefer to do this by substitution. I'm totally okay. If you're doing by substitution, you would get one of these two variables by itself. Maybe you need to subtract the G, and S would equal 350 minus G. I'm okay with that. Then you come over here in your second equation, because the first one was already, I already used it. So I come over here on my second equation and I plug in for S. In the place of S, I would plug in 350 minus G. Most of the class, we did a survey here. We asked how many of you use substitution. Very few students like to use substitution. The majority of you like to use elimination. So I'm going to go with the majority and I'm going to solve this by elimination. But I personally find substitution very easy as well. So, because you guys asked me to use elimination, here we go. I want to eliminate one of these variables. Why not the S? Okay. So in order for the S to be eliminated and add up to 0, I want to get a 0 in here. This would have to be a -3. So very fair. I'm going to multiply the entire top equation by -3. This is for students that wanted substitution. Okay. So use substitution. So I'm going to multiply by -3. That means I'm going to multiply the first variable, the second variable, and how many. You have to multiply every single thing, okay? So let's rewrite this brand new equation. Okay, here we go. I'm going to rewrite my brand new equation. The bottom one, I didn't change. It's 3S plus 5G equals 1,450. But the top one is going to be changed. It's going to become -3S, because we're multiplying it, times 3g, which equals a negative 3 times 350. If you use your calculator, you're going to get negative 3 times 3 is 9, 1,050. Okay? If you multiply it. Check your calculator. And there you go. Now I have opposite variables here. I can add these two equations together so I can eliminate the s's. So negative 3s plus a positive 3s is 0. I'm not going to write it. They're gone. A negative 3g with a positive 5g is 2g, and that equals negative 1050 with positive 1450. That's just 400. Okay? If you divide by 2 on both sides, I don't have room here, but if I divide by 2 on both sides, we get that the g equals 200. So look at that. General admission, I know it's general because I'm using the letter G. I sold 200 tickets. So let's go back to the beginning, right at the beginning somewhere here, right here for equation number 1. I sold 200 general tickets. I know a total was 350. 350 total. If 200 was general admission, minus 200 for general, minus 200 for general, then that means that leaves me with 150 for students. Okay? So see how it pays to keep track of your variables. I solved it for G, so I know I'm talking about general. And then you subtract from your total, you know that you have 150 students' tickets. Because I ran out of time, I just want to say, write a little sentence, okay? I sold blah, 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 200 general tickets and 150 student tickets. Okay, it just makes sense to write a nice little sentence explaining what you found. All right? And if you had done by substitution, you would still find exactly the same values, the exact same answer. Does it make sense? 200 plus 150, does that equal 350? Yes, it does. You can check that. 200 plus 150, it does equal 350. Okay, my numbers make sense. All right? And if you even want to check further, if you want to plug it in here and say, well, does 3 times 150 plus 5 times 200, does that add up to 1450? So just check it. It should work. So that's how you solve these problems. It is just a matter of writing two equations. I'm going to get you started. I think I have 1 minute left, and I had planned 3 problems. I'm going to get you started on this other one here. At an Italian bistro, the cost of 2 plates of spaghetti and 1 salad is $27.50. So if I buy 2 spaghettis and 1 salad, I have to pay $27.50. Now, the cost of 4 plates of spaghetti, so 4, I'm hungry. So instead of 2, I'm buying 4 plates of spaghetti and 3 salads. That would cost $59.50. Find the cost. I'm talking about money, okay? Find the cost of the plate of spaghetti and the cost of plate of salad. I'm going to write 2 equations, okay? And let's first of all decide what variables we're going to use. Well, I don't want to use S for spaghetti and S for salad. So for spaghetti, oh, there's a H, spaghetti, I'm going to use X, and for salad, I'm going to use Y, okay? So definitely because I don't want to use S and S or anything different, okay? So there we go, X and Y. Now let's write our equation. So let's read sentence number 1. 2 plates of spaghetti, 2 of the X, 2 times the spaghetti, plus 1 salad. So just one of the Y's, 1 Y. That would equal $27.50. That is how much it would cost. My second equation is similar, but now it's a different number of how many plates I'm buying it. 4 plates of the spaghetti plus 3 of the salads would equal $59.50. Okay, so I already used $27.50 for this combination of plate of spaghetti and salad. Now $59.50 for this combination of how many spaghettis? 4 spaghettis and 3 salads. So now you have your little equation set up. Choose which method you want to use here. I would use elimination. I would multiply my top one by -2, so I would have a -4 here. Okay. I'll let you finish it. I'm sorry I didn't get time to finish here. The bell rang. So I got you all set up. Solve it. Come and show it to me. See if you did it right. Okay? You can do this. Good luck.